How do sigma-algebras represent the information that an observer knows? We'll start by revising a mental model of probability theory. So most people describe the sample space, capital Omega, as a collection of outcomes, but I like to call them possible universes. And this is related to the idea that when something random in the universe happens, the universe splits into two or more universes where a different outcome happens in each one. In this particular example, we have a collection of 6 possible outcomes / universes labeled omega sub 1 to omega sub 6, and on the left here we have brief descriptions of what happens within each universe. So for example, in universe omega sub 3, the clock remains silent at 12 AM, followed by a flash of lightning. And just for the sake of this example, we're going to assume that lightning makes no noise, so there's no thunder. So let's consider observers who live within the universe, and we're going to assume that they know about what happens within each universe. So what that means is essentially they're given this information, exactly what's written here, and their goal is to determine which universe they live in. So they don't know what universe they're in, however they are able to narrow it down based on clues they're given. And these clues might be through their eyes or through their ears. So the information an observer has about what universe they're in can be represented by a sigma algebra. And you can think of a sigma algebra as just a partition of our sample space omega into groups, where each group contains universes that an observer would not be able to tell the difference between. So that's why they're called indistinguishable sets. For example, let's draw the sigma algebra that represents the information of this blind man, or the information that that blind man has. So a blind man can only use sound, and so after all these events have occurred, he's only able to distinguish between whether the clock struck 12, whether the clock was silent, or whether the clock explodes. However, he has no information about whether lightning struck or not, because he's blind. So because of that, he cannot distinguish between universes omega 1 and omega 2. So these two universes are indistinguishable from the perspective of the blind man. And that's why this set is called an indistinguishable set. We're going to move on to the deaf man. Note that the same person at 2 different points in time should be considered 2 separate observers. And this is because the observer at 1 AM has a different amount of information to the observer at 12 AM. We're going to start with the deaf man at 12 AM. Since the deaf man can only use his eyes to determine what universe he is in, he cannot distinguish the clock striking 12 from the clock remaining silent, because you can't distinguish between these two scenarios just by sight and vision alone. So these form one indistinguishable set, whereas he can distinguish these scenarios from the cases where the clock explodes, because that's something that's actually visual. Note that since this is at exactly 12 AM, the lightning has not happened yet, and therefore this deaf man is unable to use the information from the lightning to make further decisions about what universe he is in. And thus this is the most he is able to narrow it down. Moving on to the deaf man at 1 AM, this deaf man has now obtained the information due to the presence or the absence of lightning, and therefore he is able to further divide up this partition into smaller indistinguishable sets. So now this blind man can distinguish between universes where lightning happens and where no lightning happens, and therefore he can break this setup into these 2 pieces, and furthermore he can break this entire set of 4 into these 2 pieces. And note that he still cannot distinguish between omega 1 and omega 3 because the only difference between them is the behavior of the clock, but these two behaviors of the clock are identical from the perspective of a deaf man. Okay, so far we've discussed what it means to obtain a sigma algebra that represents the information that an observer has about what universe they're in. Now we're going to try to go the other direction, which is to answer the question, how do we obtain information from a sigma algebra? And we can do this through the notion of an oracle, and this concept is used in computer science a lot, and it just represents a source of information in a very abstract way. So an oracle is just something where you can ask it a question and it responds. And these questions must be of a very specific form. So for this particular oracle, we're going to give it a sigma algebra. And for example, here we have the sigma algebra that represents the information of a blind person. So as you can see, he can distinguish the universes where the clock strikes 12 from the universes where the clock is silent, from the universes where the clock explodes. So after equipping the oracle with a sigma algebra, you can then ask the oracle a series of questions of a very particular form. So you can only ask the oracle these yes or no questions, where the question must be of the form, am I inside any of these universes? Followed by a set of universes, where this set must be a member of this sigma algebra. And it turns out that the information you obtain from this oracle is exactly the same as the information you would obtain from a blind person. So for example, we can ask the oracle, am I in any of these universes? And the oracle is going to say no. And then you ask, am I in any of these universes? And the oracle is going to say yes. So in the end, you've narrowed down what universe you're in to exactly these two, but you're not able to narrow it down any further than that. And this is exactly the experience of the blind person. The blind person would also only be able to narrow it down this far.